Good evening, my dear students. Welcome to my channel Designed to Learn with Mukesh. So today in this video, we are going to discuss the first chapter from NCERT class 9th science, that is your matter in our surroundings. Matter in our surroundings. So today we are going to discuss. Before starting the lesson, we will discuss the objectives, what we will learn from the chapter. So the objectives of today's lesson are: after completion of the chapter, the children will be able to 1. Explain practical natures of matter. 2. Some physical processes like fusion, evaporation, boiling, sublimation, etc. Then they will be also able to explain about states of matter and interchange in states of matter. Then differentiate between evaporation and boiling and conversion of Kelvin and Celsius scale. So these are the objectives of today's lesson. First of all, we will see what is matter. Everything in this universe is made up of material, that is called matter. So everything you see in this universe is made up of tiny particles, and those particles are called your matter. Short notes. Introduction. Matter. Matter is anything that occupies space and has mass. So anything that has a specific mass which we can measure and that occupies space will be called as matter. Matter is the form of five basic elements, the Panchatattva. Those are air, earth, fire, sky, and water. So these are the five things that is matter made up of. There are three types of matters: solid, liquid, and gases. On the basis of chemical composition, matter can be classified as pure substances and mixture. Pure substances are either elements or compounds, and mixtures may be homogeneous mixture or heterogeneous mixture. So about pure substances, about elements, compound and mixtures, different types of mixtures, we will discuss in the following chapters. Properties of matter. Matter is anything which occupies mass and has space. Each matter is a collection of lots of tiny particles. Particles of matter are continuously moving. Then particulate nature of matter. Particulate nature means that matter is made up of very small particles, tiny particles. These particles are either atom, molecules or ions. We will discuss more about atoms, molecules and ions in the following chapters, in the upcoming chapters. Following properties are associated with particulate nature of matter. 1. The particles of matter have space between them. 2. The particles of matter are continuously moving. 3. The particles of matter attract each other. 4. The particles of matter are very tiny. Tiny means very small. Then the particles of matter are very tiny. So how can we prove this? By experiment. So here is an activity. Dissolve 2 or 3 crystals of potassium permanganate in 100 ml of water in a beaker. Then take 10 ml of this solution and dissolve in 100 ml of water. Take 10 ml of this solution and dissolve in 100 ml of water. Repeat this process 5 to 6 times. So this shows that a few crystals of potassium permanganate can color a large volume of water because there are millions of tiny particles in each crystal. So you can do this experiment in order to prove that the particles of matter are very tiny. Then the particles of matter have space between them. To prove this, we will have an activity. Take some water in a beaker and note its level. Dissolve some salt or sugar in it with the help of a glass rod. The salt dissolves in the water, but the level of water does not change. This is because the particles of salt get into the space between the particles of water. So from this experiment, we can prove that we found that the particles of matter have space between them, because here the salt particles or the sugar particles find the space between the water particles. They dissolve between the water particles. Then particles of matter are continuously moving. To prove this, we can have an activity. Take some water in a beaker and put a drop of blue or red ink slowly along the sides of the beaker. Leave it undisturbed for a few hours. The ink spreads evenly throughout the water due to the movement of the particles of water and ink. The intermixing of two or more different types of matter on their own is called diffusion. So, the intermixing of two or more different types of matter on their own is called, that is a process. This process is called diffusion. So, here the ink particles diffused in between the water particles. So, particles of matter are continuously moving. Particles of matter attract each other. So to prove this, we have an activity. Take an iron nail, a piece of chalk, and a rubber band. Try breaking them by hammering, cutting, or stretching. It is more easier to break the chalk, less easier to break the rubber band, and difficult to break the iron nail. So this is because the particles in the iron nail are held together with greater force than in the rubber band and chalk. So the force of attraction between the chalk particles is least and the force of attraction in between the iron nail is maximum as compared to rubber band and chalk. So it is easier to break the chalk, but it is difficult to break the iron. Five states of matter. There are five states of matter: solid, liquid, gas, plasma, and Bose-Einstein condensation. So solids have fixed space and definite volume, but liquid have do not have fixed shape but fixed volume they have. Gas, they neither have fixed shape nor have fixed volume. Then solid interparticle distances are smallest. In case of liquid, interparticle distances are larger. In case of gas, interparticle distances are largest. Interparticle distance means the distance between the particles. That is the matter made up of. Then solid is incompressible, which cannot be compressible, and liquid is almost incompressible, and gas is highly compressible. We can compress the gas. Then solid has high density and do not diffuse, but liquid density is lower than solid and diffuse, easily diffuse. Density is least and diffuse. In case of gas density is very least, very small, few, and it diffuses easily. Then, in case of solid, inner particle forces of attraction are strongest. So it is very difficult to break the solid. And in case of liquid, interparticle forces of attraction are weaker than solids. And in case of gas, interparticle forces of attraction are weaker. So we can easily what we call push. We can change the place of gas by applying pressure. Or yes, then in case of solid, constituent particles are very closely packed. In case of liquid, constituent particles are less closely packed, and in case of gas, each constituent particles are freely to move about, are free to move about. Then plasma. A plasma is an ionized gas. A plasma is a very good conductor of electricity and is affected by magnetic fields. Plasma, like gases, have an indefinite space, shape, and an indefinite volume. Example, ionized gas are in plasma state. Then Bose-Einstein condensation. A Bose-Einstein condensation is a state of matter that can arise at a very low temperature. The scientists who worked with the Bose-Einstein condensation received a Nobel Prize for their work in 1995. The Bose-Einstein condensation is all about molecules that are really close to each other, even closer than atoms in a solid. So they are very closer, also more than in case of solid. And this Bose-Einstein condensation state arises when there is very low temperature. Then microscopic explanation for properties of solids. Solids have a definite shape and a definite volume because the particles are locked into space. Solids do not flow easily because the particles cannot move or slide past one another. Solids are not easily compressible because there is a little free space between particles. Then microscopic explanation for properties of liquids. Liquids are not easily compressible and have a definite volume because there is little free space between particles. Then liquids have an indefinite space because the particles can slide past one another. Then liquids flow easily because the particles can move or slide past one another. Then microscopic explanation for properties of gases. Gases are easily compressible because there is a great deal of free space between particles. Gases flow very easily because the particles randomly move past one another. Gases have an indefinite shape and an indefinite volume because the particles can move past one another. Then microscopic explanation for properties of plasma. Plasmas have an indefinite shape and an indefinite volume because the particles can move past one another. Plasmas are easily compressible because there is a great deal of free space between particles, and plasmas are good conductors of electricity and are affected by magnetic fields because they are composed of ions. We will learn more about electricity and magnetic field in the upcoming chapters. Then macroscopic explanation for properties of Bose-Einstein condensation. Particles are less energetic than solids because exist at very low temperature. You know that Bose-Einstein condensation matter means state arises when there is a very low temperature. So particles are less energetic than solids because exist at very low temperature. Particles are literally indistinguishable because they are locked into same space. And Bose-Einstein condensation shows superfluidity because particles can flow without friction. So they can flow without friction. So that is called superfluidity. Okay. Then matter. So the three main states of matter are solid, liquid, and gases, which we are going to discuss. So first, depending on intermolecular space and intermolecular force of attraction, matter exists in three different states. Solid state have a definite space and volume. Liquid state have definite volume but no definite shape. Gaseous state neither have definite volume nor definite shape. And solids are rigid, fixed shape, fixed volume, cannot be squashed, that means cannot be compressed. Liquid not rigid, no fixed shape, fixed volume, and cannot be squashed. And gas not rigid, no fixed shape, no fixed volume, it can be squashed, that means can be compressed. Melting, solid changing into liquid, that is the process of melting. Ice, that is solid, on heating it gives water. Okay, it is called your melting. It is called your melting. And when liquid melts, it causes what we call ice like when ice melts, it gives liquid, that is water. Okay, then melting is the process in which a solid changes into liquid on heating. Then freezing, liquid changing into solid. So melting is change of solid to liquid by heating. Okay, ice changes into water when it melts, and freezing, when water freezes, it gives solid, that is ice. Okay, freezing is the just opposite of melting. When we heat, solid melts into liquid, and when we cool or freeze, liquid converts into solid. You know, in your home, in refrigerator, we freeze water to make ice, right? So freezing, that is also called solidification, process in which a liquid changes into solid on cooling. So melting occurs when we what we call when we heat. By heating, okay, ice changes or solid changes into liquid or melting occurs. And by cooling, the opposite of melting, that is freezing or solidification, occurs in which liquid changes into solid. Then vaporization, liquid changing into gas. Evaporation, process in which a liquid changes into vapor state at any temperature below its boiling point, that is called evaporation. So two kinds of evaporation are there. One is evaporation and one is boiling. Vaporization, that takes place only on the surface of the liquid. It is a surface process. And boiling, when a liquid changes to a gas below its surface as above, it is called your boiling. So boiling occurs both from below and above, but evaporation occurs from the above surface only. It is a surface process. Boiling, a process in which a liquid changes into vapor state on heating at a particular temperature, that is called boiling. But when in which the process in which a liquid changes into vapor state at any temperature below its boiling point is called your evaporation. Okay, students. Now, condensation, that is gas changing into liquid. So, process in which a gaseous substance changes into liquid on cooling, that is called your condensation. That is the opposite of your vaporization. Okay. Then sublimation. Sublimation is a special process in which solid changes into gas and gas changes into solid. So usually when we heat, solid changes into liquid, solid melts and it gives liquid, and liquid also vaporizes and gives vapor. And when we cool, by cooling, gases changes into liquid form and liquid changes into solid form. But in this case of sublimation, what occurs? Solid changes directly into gases and gases also changes into solid. So sublimation is the process of changing a solid directly into a gas on heating, or vice versa. Vice versa means gas directly changes into solid. So without passing through liquid state, it is called your sublimation. Example of sublimation, dry ice is an example of sublimation, that is dry carbon dioxide. Dry ice is solid carbon dioxide, that is solid CO2. CO2 is the chemical formula for carbon dioxide. Carbon dioxide is typically found as a gas. When it is frozen into a solid, it turns directly into a gas and totally skips the liquid stage. So this is the process of sublimation. Okay, so sublimation is a process where a solid changes from a solid to a vapor without passing through the liquid state, or a vapor changes into solid without passing through the liquid state. So examples of sublimation we can find in naphthalene balls, camphor, iodine, dry ice. Okay, these are the substances in which sublimation occurs. Okay. Then interconversion of states of matter. So states of matter can be interconverted with the two processes, either by changing the temperature or either by changing the what we call pressure. So you can see that yes, liquid changes into gas. The process is called evaporation, and the opposite, when gas changes into liquid, it is called condensation. When gas changes into solid or solid changes into gas, so the changing of gas into solid is called sublimation, sorry, deposition, and the change of solid into gas is called sublimation. So this is the process of sublimation only. Gas directly changes into liquid, solid, or solid changes into gas, so that will be called your what we call sublimation. Okay, when solid directly changes into gas, that is called sublimation, and when gas changes into solid, that is called your deposition. So the opposite of sublimation is your deposition. Then freezing. When liquid freezes, it gives solid, and when solid melts, it gives liquid. So freezing is the opposite of melting. And here, solid melts into liquid, liquid evaporates into gas, gas condensates into liquid, and liquid solidificates into solid. Okay. And when solid changes into gas directly, that is called sublimation. And when gas changes into solid, that is called deposition. So deposition is another kind of sublimation. It is just the opposite process of sublimation. So here we can mark what is A, B, C, D. When solid changes into liquid, that is called your melting. So A is melting. And when liquid changes into gas, that is B, that is called your evaporation. When gas changes into liquid, that is C, that is called your condensation. And when liquid changes into solid, that is D, that is called your solidification. And when solid changes directly into gas, that is E, that is called sublimation. And when gas directly changes into solid, that is FO, that is called deposition. So these are the processes. So the properties of solids are definite mass, volume, and shape, short intermolecular distance, strong intermolecular forces. The constituent particles remain fixed at their positions and can only oscillate about their mean position. So they are totally immovable. They only oscillate, okay, in their mean position. Solids are incompressible and rigid. High density they also have. So solids have definite shapes and fixed volume. The space between the particle is maximum. The force of attraction between the particles is maximum. The movement of the particles is minimum. Okay, they are least compressible and their rate of diffusion is least. Now, properties of liquid. So liquids have a fixed volume but no fixed shape. Liquid forms the shape of the container. Okay, if you put water into a glass, then the shape of the water will be like a gas and glass. And if you put the same water into a bucket or into a mug, then the shape will be as per the container. Liquids can be compressed. Large pressure is required to compress them. Liquids have lesser densities than solids. Intermolecular forces of attraction is weaker than solids. They have considerable space between the particles. So liquids have no definite shape but have fixed volume. Liquids take the shape of the container. The space between the particles is intermediate. That means it is in between the solid and liquid. Sorry, solid and gas. The force of attraction between the particles is intermediate. It is also between solid and gas. The movement of the particles is intermediate. They are less compressible. The rate of diffusion is more than solid. Then properties of gases. Gases have neither definite shape nor definite volume. They expand to the size of their container. Gases are fluid and flow easily. Gases have low density unless compressed. Gases diffuse, mix and spread out. That is, diffuse means mix and spread out, and effuse means travel through small holes. Then gaseous state, properties of gases. Gases have no definite shape or fixed volume. Gases occupy the whole space of the container. The space between the particles is maximum. The force of attraction between the particles is minimum. The movement of the particles is maximum. They are most compressible. The rate of diffusion is more than solids and liquids. Then difference between solid, liquid and gas. Here is a table, that is the difference between solid, liquid and gases. Solids are rigid in comparison to liquids and gases. The liquid is not so rigid as compared to solid. Gases are also not rigid. Solids have a definite shape and volume. Liquids have a definite volume but no definite shape. They acquire the shape of the container. Gases neither have definite shape nor have definite volume. Solid particles have low kinetic energy. Liquids molecules have intermediate kinetic energy. The and gases possess very high kinetic energy. Solids can't be compressed. Liquids can easily be compressed, and gases can be compressed very easily. Okay. Then solids, their molecules are held tightly by strong molecular forces. That is tightly by strong molecular forces. The liquids molecules are held tightly at an intermediate level, and in case of gas, very weak attraction forces are present among the molecules of gases. Solids are present in a very dense form. Density is in case of liquid, density is present at an intermediate level, and in case of gas, gases possess very low density. So density is your mass divisible by volume. Solids cannot flow easily, and liquids are knowing by flowing property they can flow, and gases flows and evaporates easily. In case of solid, the diffusion rate is very low. In case of liquid, the diffusion rate is moderate. That means more than solid but less than gas. And in case of in case of gases, diffusion, the rate of diffusion is very high, more than solid and liquid. Changing state of matter, we can change the state of matter either by temperature and pressure. Okay. If there is a gaseous state, if you decrease temperature or increase pressure, then it will be liquid state. And when liquid, if you decrease temperature or increase pressure, it will be a solid state. Okay. When solid, if you increase temperature or decrease pressure, it will be into liquid state. And in liquid, when you increase temperature or decrease pressure, it will be your gaseous state. Change of state. When a solid is heated, it changes into liquid. And when a liquid is heated, it changes into gas. When a gas is cooled, it changes into solid. When a liquid is cooled, it changes into solid. Sorry, when a gas is cooled, it changes into liquid. And when a liquid is cooled, it changes into solid. Example, if ice is heated, then it will changes into water. If water is heated, it changes into steam or water vapor. If steam is cooled, it changes into water. And if water is cooled, it changes into ice. Then melting, that is called fusion. When a solid is heated, the particles begin to vibrate with greater speed and begin to move more freely. Then at a particular temperature, the solid melts and changes into liquid. The process of melting is also known as a fusion. The temperature at which a solid melts is called the melting point. The melting point of ice is a 0 degrees Celsius or 273 Kelvin. Then latent heat of fusion. The amount of heat energy required to change 1 kg of a solid into liquid at atmospheric pressure at its melting point is called the latent heat of fusion. Then melting, fusion and melting point. The process in which a solid substance changes into liquid on heating is called melting or fusion. The melting of a solid substance takes place at a fixed temperature. The temperature at which a solid substance melts and changes into liquid at atmospheric pressure is called your melting point of substance. That is, melting point of ice is 0 degrees Celsius or 273 Kelvin. The melting point of a solid is an indication of the strength of the force of attraction between its particles. Then boiling. When a liquid is heated, its particles begin to move even faster. Then at a particular temperature, the liquid begins to boil and changes into gas. That is vapor. Boiling is a bulk phenomenon. When a liquid boils, the bulk of the liquid changes into vapor. That means the upper surface. Okay. The temperature at which the whole surface boiling is occurred the whole surface below and upper both. But evaporation is only occurs at the surface area. But boiling occurs is a bulk phenomenon means it occurs both in the above portion and in the below portion, both portion. The temperature at which a liquid starts boiling is called its boiling point. The boiling point of water is 100 degrees Celsius or 373 Kelvin. Latent heat of vaporization. The amount of heat energy required to change 1 kg of a liquid into gas at atmospheric pressure, it is called a boiling point. At its boiling point is called the latent heat of vaporization. So the amount of heat energy required to change 1 kg of a liquid into gas at atmospheric pressure at its boiling point is called the latent heat of vaporization. Then boiling and boiling point, the process in which a liquid substance changes into a gas rapidly on heating is called boiling. The boiling of a liquid substance takes place at a fixed temperature. The temperature at which a liquid boils and changes rapidly and into gas at atmospheric pressure is called boiling point of the substance. That is, boiling point of water is 100 degrees Celsius or 373 Kelvin. The boiling point of a liquid is a measure of the strength of the force of attraction between its particles like solids. Then latent heat. What is latent heat? The heat energy which has to be supplied to change the state of a substance is called the latent heat. It is called latent heat because it becomes hidden in the substance undergoing the change of state and does not show its presence by raising the temperature. When a substance changes into state of another substance, then the temperature remains constant. Only the state changes. So the temperature that is being observed that causes the change in state, and that temperature is called the latent heat. Then types of latent heat, there are two types of latent heat. First one is latent heat of fusion and second one is latent heat of vaporization. So latent heat of fusion, the latent heat of fusion of a solid is the quantity of heat required to convert unit mass of solid at its melting point in liquid without any change in temperature. The latent heat of fusion of ice is 3.34 multiplied by 10 to the power 5 joules per kg. Then the latent heat of fusion of ice is 3.34 multiplied by 10 to the power 5 joules per kg. What does it mean? Latent heat of fusion of ice is 3.34 multiplied by 10 to the power 5 joules per kg. It means that 3.34 multiplied by 10 to the power 5 joules of heat energy is required to change 1 kg of ice at its melting point into water at the same temperature. This means 1 kg of ice at 0 degrees Celsius has 3.34 multiplied by 10 to the power 5 joules of less heat than 1 kg of water at the same temperature. So ice at 0 Celsius is more effective in cooling a substance than water at 0 degree Celsius. Why the temperature of melting ice does not rise even though heat is being given continuously. So this is the case of latent heat. Ice is solid substance. The particles of ice attract one another with strong forces. The heat which we supply to ice during melting is used to overcome the forces of attraction between the ice particles so that they become loose and change into water. This latent heat does not increase the kinetic energy of particles and hence no rise of temperature takes place during melting of ice because the heat here observed is used in change of state. That is called the latent heat. So the temperature does not rise. Then latent heat of vaporization. The latent heat of vaporization of a liquid is the quantity of heat required to convert unit mass of liquid at its boiling point to vapor or gas without any change in temperature. So here also temperature does not change, only the state changes and the heat is used to change the state. That is called the latent heat of vaporization. And latent heat of vaporization of water is 22.5 multiplied by 10 to the power 5 joules per kg. So the latent heat of vaporization of water is 22.5 multiplied by 10 to the power 5 joules per kg. What does it mean? The latent heat of vaporization of water is 22.5 multiplied by 10 to the power 5 joules per kg. It means that 22.5 multiplied by 10 to the power 5 joules of heat energy is required to change 1 kg of water at its boiling point into vapor at the same temperature. Why the temperature of boiling water does not rise even though heat is being given continuously? Because it is also the case of latent heat. Water is a liquid substance. The particles of water attract one another with certain forces. The heat which we supply to water during boiling is used to overcome the forces of attraction between water particles so that they become totally free and change into gas. This latent heat does not increase the kinetic energy of water particles, and hence no rise of temperature takes place during the boiling of water. Only the latent heat is used to change the state. So effects of temperature on molecular motion, you can see here in case of solid, okay, in case of liquid also, when we increase the temperature, the molecular motion increases also. The what we call space between the particles increase. Then sublimation. So the change of state directly from solid to gas or from gas to solid is called sublimation. Actually, the process of change of gas to solid is called deposition, but uh, this is one type of what we call sublimation. If solid camphor or ammonium chloride is heated, it changes into vapor. If the vapors are cooled, it changes into solid. So aluminum chloride, okay, and camphor, these are the volatile substances. These are called volatile substances, which changes directly solid to gases. Then interconversion of the three states of matter. Already we have discussed how what are the processes. Okay, when okay the three states of matter changes. What are the processes called? Already we have discussed. So effect of pressure on gases. When pressure is applied on gas, the particles come closer and the gas changes into liquid. Already we found that two what we call things are there by which we can change the state of matter. One is your temperature and one is your pressure. So already we've discussed about temperature, now we'll discuss about pressure. So when pressure is applied on gas, the particles come closer and the gas changes into liquid. When we liquefy gases by applying pressure and reducing the temperature, okay, so you can liquefy gases in LPG, we liquefy gases, okay, liquefied petroleum gas that is called, we use in our house, okay. Compressed solid carbon dioxide is called dry ice. So when we compress solid carbon dioxide, that becomes dry ice. If the pressure is reduced, it changes directly to gas without coming into liquid state. So solid carbon dioxide is known as a dry ice. Evaporation. The change of a liquid into vapor at any temperature below its boiling point is called evaporation. Evaporation is a surface phenomenon. It occurs in the surface of the liquid. Particles from the surface gain enough energy to overcome the forces of attraction and changes into vapor state. And so evaporation is a process in which a liquid changes into vapor or gas even below its boiling point, and it is a surface phenomenon. It occurs at the surface of the liquid. Okay. So liquid high energy molecules, gas, water vapors, changes into gas, that is water vapor. Okay. So in case of liquid, less force of attraction and less force of attraction. And when the temperature rises, more force of attraction occurs, and more force of attraction occurs into less force of attraction, and the liquid gets free, and the upper portion of the liquid gets evaporated. Then factors affecting evaporation. The rate of evaporation depends upon surface area, temperature, humidity, and wind speed. We will discuss one by one. Increase in the surface area increases the rate of evaporation. Increase in temperature increases the rate of evaporation. Increase in humidity decreases the rate of evaporation. Humidity means presence of water molecules, water particles in the air. So when there is water particles in air, how can diffusion, how can evaporation can occur? So humidity decreases the rate of evaporation. Increase in wind speed increases the rate of evaporation. We will discuss one by one. So these are the factors affecting the evaporation. So temperature, as the temperature increases, the rate of evaporation also increases. Okay. Temperature is directly proportional to rate of evaporation. It is so because when we increase the temperature of our heating source, we supply more energy to the liquid. So this energy is stored in the form of kinetic energy of the molecules. Then humidity, the rate of evaporation decreases with increase in humidity. Humidity means presence of water particles, water molecules in the air. More is the humidity in atmosphere, more water vapor will be present in atmosphere, and there will be very less space for more water vapor. Hence evaporation decreases. Then surface area, as the surface area increases, the evaporation also increases. The surface area affects evaporation because if more area is exposed to air, allowing water molecules acquire more heat energy from the surrounding. So due to the increased heat energy and energy, there is more rapid movement of the water molecules, which helps them to overcome the force of attraction and evaporate. Then wind speed. Increase in wind speed results in increase in evaporation. Particles of vapor move away when the speed of wind increases. This leads to a decrease in the amount of water vapor in the atmosphere. For example, we use hand dryers to dry our hands. Here the wind is expelled from the hand dryer which dries our hand. So when speed of wind increases, then evaporation also increases. Then temperature. The rate of evaporation increases on increasing the temperature of the liquid. So rate of evaporation of a liquid can be increased by heating it. Okay. If you heat a liquid, then it will be evaporate. When you raise the temperature, the rate of evaporation will be also increased. Surface area of the liquid, the rate of evaporation increases on increasing the surface area of the liquid. If the surface area of a liquid exposed to air is increased, then the rate of evaporation is also increases. So here you can see that when you put a wet material, a wet cloth, okay, by unfolding it, then the surface area increases, so it becomes dry sooner. But when you put the same cloth, wet cloth, okay, by not unfolding it or by folding it, then the surface area decreases, so it becomes dry. It becomes dry. It takes so much time to becomes dry. Okay. Then humidity of air. The amount of water vapor present in air is called the humidity. So humidity of air tells the degree of deep dampness of air. So when there is the humidity of air is low, the rate of evaporation is high because there is more what we call there are only what we call there is less water particles in the air. So there is very what we call the space for the water molecules that will be evaporated. But there is a high humidity. If there is a high humidity, then there will be no space or less space for the water molecules, and there will be more water in the air. So there will be low rate of what we call evaporation. Okay, you can see clear sky and rain season. In case of clear sky, that is in case of winter and summer, evaporation is fast because the presence of water molecule in water vapor in the air is very low. But in case of rainy season, there are water molecules or water vapor in the air, so evaporation is very slow because humidity is high in case of rainy season. Okay, wind speed. The rate of evaporation increases on increasing the wind speed. When the speed of wind increases, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surrounding, and this increases the rate of evaporation of water. So when there is the speed of wind increases, then the evaporation rate of evaporation also increases. So we unfold the wet cloths in such area where there is a flow of wind is available. Wind flow is available. The nature of the liquid. The lesser the boiling point of a liquid, more is its tendency to change into vapor. Thus, more volatile liquids having low boiling point, more volatile liquids mean having low boiling point, evaporates faster than less volatile liquids, that means having high boiling point. The liquids which have high boiling point are called volatile liquids, and the liquids which have low boiling point are called volatile liquids. Okay, so evaporation causes cooling. Evaporation causes cooling. How? Surface molecules absorb heat, then increase kinetic energy of molecule, then overcome force of attraction, then escape out into gas or water vapor. So decrease the kinetic energy of remaining molecules, that is cause cooling. Okay. Example of cooling effects of evaporation: cotton fabric. Okay, cotton fabric absorbs heat, In summer season, we wear cotton cloth. Evaporate through small cotton pores, cause cooling and comfortable effect. Example of cooling effect of evaporation. You can see air cooler. Okay. Example of cooling effect of evaporation: sprinkling water on floor or roof. When we sprinkle water on floor or roof, surface molecule absorb heat. Okay, increase kinetic energy of molecules, overcome force of attraction, then escape out into gas or water vapor. Decrease the kinetic energy of remaining molecules or cause cooling. Finally, examples of cooling effect. Another example: ether acetone in palm. When we pour some acetone or ether in palm, surface molecules absorb heat, increase the kinetic energy of molecules, overcome force of attraction, then escape out into gas or water vapor, decrease the kinetic energy of remaining molecule, and finally causes cooling. So evaporation causes cooling. When a liquid evaporates, the particles of the liquid absorb heat from the surrounding and evaporates. So the surrounding becomes cool. Example, people sprinkle water on the roof or open ground because during evaporation, water absorbs heat, makes the hot surface cool. During summer, we sweat more. We sweat more because during evaporation, the sweat absorbs heat from our body, making the body cool. Wearing cotton clothes in summer keeps us cool because cotton absorbs heat, and when the sweat evaporates, it absorbs heat from our body, making the body cool. Then evaporation of liquid causes cooling. Okay, surface molecules absorb heat. Then this is the process. This is the schematic process how it causes cooling. So surface molecules absorb heat, then increase kinetic energy of molecules, then overcome force of attraction, then escape out into gas or water vapor, then decrease the kinetic energy of remaining molecules, and then finally causes cooling. Cooling caused by evaporation. Okay, so we already discussed about how cooling causes by evaporation. Okay, you can see the cooling caused by the evaporation is based on the fact that when a liquid evaporates, it draws the latent heat of vaporization from the object which it touches. By losing it, the object gets cool. When a body loses heat, it becomes cool. Some examples of cooling caused by evaporation from daily life. If we put a little spirit, alcohol, or perfume at the back of our hand and wave it around, they evaporate rapidly and our hands feel very cold. During hot summer days, water is usually kept in earthen pot or matka. Okay, due to this phenomenon, it becomes cool, it remains cool. Okay, at many places, especially in village, people often sprinkle water on the ground in front of their homes during the hot summer evenings. We should wear cotton clothes in hot summer days to keep cool and comfortable. Okay. Then a desert cooler or cooler better on a hot and dry day. We are able to sip hot tea or milk faster than saucer than for make cough. Here, the surface area comes to effect. Okay, in case of what we call cough, there is a low surface area or less surface area exposure to air. But in case of saucer or plate, there is what we call more surface area. So if surface area increases, then evaporation also increases. Already we have discussed. Then boiling, already we have discussed about boiling. Okay, so what is the difference between boiling and evaporation? Boiling is the process by which a liquid turns into vapor when it is heated to its boiling point. But evaporation is the process of conversion of a liquid into vapors at any temperature below its boiling point. In the process of boiling, bubbles are formed, but in the process of evaporation, bubbles are not formed. And boiling is faster than the process of evaporation, and evaporation is lower than the process of boiling. So these are the differences between boiling and evaporation. Okay, and boiling occurs at a definite fixed temperature, that is boiling point, but evaporation occurs at any temperature or all temperature. In the process of boiling, temperature remains constant. Okay, the latent heat is only used in the changing of state, and evaporation, the process of evaporation, temperature may change. Then in boiling, energy is supplied by a source of energy, and in evaporation, energy is supplied by the surrounding, which causes the surrounding cool. Evaporation causes cooling. Then conversion of Kelvin and Celsius scale. Kelvin is the SI unit of temperature. That is the standard unit of international unit of temperature. 0 degree Celsius equal to 273.16 Kelvin. We take 0 degree Celsius equal to 273 Kelvin. So SI unit of temperature is Kelvin. Okay. And to find Kelvin, we have to add 273 with Celsius because 0 degree Celsius because 0 degree Celsius equal to 273 Kelvin. Kelvin scale of temperature has always positive sign, hence regarded as a better scale than Celsius because it is only positive sign. but Celsius may have a negative sign. Atmosphere ATM is a unit of measuring pressure exerted by a gas. The SI unit of pressure is Pascal. 1 atmosphere is equal to 1.01 multiplied by 10 to the power 5 Pascal. The pressure of air in atmosphere is called atmospheric pressure. The atmospheric pressure at sea level is 1 atmosphere and is again is the normal atmospheric pressure. Then to convert Celsius to Kelvin, we have to add 273 with the given Celsius amount, and to convert Kelvin to Celsius, we have to subtract 273 from the given Kelvin unit. For example, convert the given temperature to the Celsius scale, 293 Kelvin. So to convert Kelvin scale into Celsius scale, we have to subtract 273. So 293 Kelvin, 293 minus 273 equal to 20 Celsius. So 293 Kelvin equal to 20 Celsius. To convert Kelvin into Celsius, we have to only subtract 273 from the given Kelvin amount. And to convert Celsius into Kelvin, we have to add 273. For example, convert the given temperature of the Kelvin scale to Kelvin scale, 25 degrees Celsius. So to convert Celsius scale into Kelvin scale, we have to add 273. That is 25 degrees Celsius. So equal to convert into Kelvin, we have to add 273. So 25 plus 273 equal to 298 Kelvin. So students, thank you so much for watching the video. So with this video, we learned about different states of matter and about matter, what is matter, types of matter and states of matter, interconversion of states of matter, and some processes like fusion, diffusion, evaporation, melting, boiling, evaporation, how evaporation causes cooling, what are the factors that affect evaporation. Okay, these are things. And in the upcoming chapter, we will discuss more about different processes, more about atoms and molecules and different factors of physics, chemistry, and different topics from the science chapter of your class. So thank you once again. Keep learning, keep growing. We will meet soon in another video. Till then, bye. Thank you.